Welcome back to Portable Power Repair Secrets. Well, it's mid-July 2024. Mid-July is vacation time, camping season, boating season, and that means there's no shortage of portable power packs at the store. So this week I picked up two. First one's a Duracell 750. Looks brand new, there's not a mark on it. And the second one is this Stanley 1000 peak amp unit. Pretty dirty. I've looked up both of these on the internet. This one's about $100 at Home Depot, and so is that one. Most places though get between $130 and $150 for this one. So we have roughly $200 worth of portable power packs here. Let's see if we can figure out why they were thrown away. Let's see if we can get them fixed. Now, neither one of these would light any of the battery lights when I first picked them up. So I had them on charge actually for 2 days. This one still will not light any of the lights. This one though, press the battery status, all three of these lights turn on, even the green one. So we have some life on this battery. Let's decide which one we're going to start with. Alright, the first thing I notice on this one, if you shake it, there's something rolling around inside of it. So that's not good. And then the alligator clips, both of them, they're really corroded, all rusty and corroded, not making good contact. And the whole unit looks like it's been kept outside. It's absolutely filthy, but it does turn on and work. Look how corroded this one is. So it's going to need some new alligator clips, and we have to find out what's rattling around inside. So okay, for the minute we'll just put this away, but it did take a charge and it does work. So let's see, when light comes on, see, the compressor works. Here's the air hose. So yeah, it's filthy, needs new alligators, but it does work. But there is something loose inside. So looks like a little bit of work on this one. Alright, what about this other one? This one looks brand new. There's not a mark on it. Yet it does not work. What do we got in here? That's the air compressor cord. So we get nothing. We try to turn on the light, which is right here. Light does not come on. So I think I'm going to start with this Duracell 750 just because it's so clean. Let's see if we can figure out why this baby doesn't work. Now, to test these out, you're going to need a multimeter. This is the latest inexpensive Harbor Freight meter. It's a lot better than the red ones they're selling today. So if you don't have a meter, I'd recommend at least something like this. I'd stay away from the red ones. There's two big problems with the red ones they're selling today. The test leads. The test leads fall apart almost immediately, and you'll see that in lots of guys' videos online. The other thing that's wrong with the red ones, this is known as the function and range switch. It doesn't read continuity very well on the red ones. It's very inaccurate. You've got to wick it back and forth like this just to get it to read right. No good. This one though works pretty good. They're around $15 if you get them on sale with coupon. It has a lot of features the red ones don't have. It has a light so you can see it in the dark. It has a hold switch. Yeah, if I were teaching a class today, I would recommend that students start with at least something like this. Stay away from the Harbor Freight red ones. So when you get it, and the reason I'm mentioning this because we get a lot of comments and I know people don't know how to use a multimeter. That's half the reason they throw these away. So you got a black lead, goes into the common jack. Then you got a red lead, goes into this one, volts, ohms, milliamps. Alright, they're both plugged in. And where do you put the function and range switch? Well, this is DC volts right here. This would be 600 millivolts, that's 6/10 of a volt. 6,000 millivolts, that would be 6 volts. Kind of a strange marking. This one is 60 volts. These are 12 volt power packs, so we want to put this on 60 volts. Okay, DC. Now, one of the things that most people don't realize, you can check the condition of a power pack just by clipping on these jump cables. So I put red to red, black to black. I'm going to turn it on. Oh, we're not reading much right here. I'm going to turn on this jump start power. Make sure they're not touching each other. And this is telling me that the battery, not that good. I'm only getting 10.3. This would not start a car. Would run some LED lights though, and it's also running the compressor, at least for a little while. But this tells me immediately, look at it dropping. This has been on charge for 2 days, it needs a battery. So they threw this away because it needs a battery and because the alligator clips are corroded. Can we fix it? Yep, but not today. We're going to look at the clean one. So okay, let's do the same test with the clean one. Alright, we're going to turn the jump start power on. Now here's something I see right away. There's some black stuff here. This is carbon. Something must have really sparked when they connected this. See it? So this has been used and something really sparked here. You wouldn't have that carbon? Let's see what we get for a reading. This one's quite a bit cleaner. A little bit of carbon or some black stuff right here. And we see that we've only got 3 volts. Well, 3 volts is not going to run any 12 volt equipment, so that's telling us we also have a dead battery in this Duracell. So let's take it apart and see if it's due to corrosion or if the battery itself is actually dead. Okay, so right off the bat, I'm seeing 7 Phillips head screws. 1, 2, 3, 4, 5, 6, 7. I'm seeing a lot of corrosion here where the black alligator clip was normally connected. We'll check the air hose compartment because you never know if there's going to be a hidden screw in here. I don't see any hidden screw, so let's go after these 7. So this is a Pittsburgh #2 Phillips 4-inch screwdriver. This is a very cheap Harbor Freight set. And yet, I find that these tips are ground differently than Craftsman screwdrivers, and they seem to work a lot better removing screws. Chrome vanadium shaft. These were very inexpensive and I like them. Now, while we're on the subject of screwdrivers, how do you magnetize the tip so that it pulls those screws out and they don't get stuck down in the holes? This is a little magnetizer, demagnetizer. They're only $2 or $3. Probably $3 or $4 today because of inflation. And all you do is stick the screwdriver tip in the hole to magnetize it. And now, well, the magnet in here is stronger. Now it'll pick up any screw. So, very, very useful tool. If you don't have any tools at all, this cheap Harbor Freight set, very good. You definitely want one of these magnetizer demagnetizers. Originally these come with O-rings, and this magnet is so strong the O-rings will crack and then this separates. So you just put it back together with tie wraps like I did. So these are the tools you need: screwdriver, magnetizer, demagnetizer. Now, the reason I'm spending so much time talking about the tools, talking about the multimeter, is because 9 out of 10 comments that I get on portable power packs are from people with dead batteries. And they want to change those batteries, they just don't know how to do it. As simple as it is, if no one has ever showed you, then it becomes complicated. It's not really complicated. So we have maybe $20 worth of tools here that belong in everybody's tool chest. A really nice multimeter. I'll say this one's pretty nice. Some nice screwdrivers that actually are ground properly so that they grab the screws and pull them out of the holes. Yeah, cheap tools, but very, very nice. At least these are. So that's part of the secret. You want some nice tools. And a little instruction is very, very easy to use them. Now let's get this thing apart. It's going to be a connection to the light as well. Oh, so see, for a charger, this actually just uses an AC adapter. Here's your air pump. These wires go to a couple of plugs that are plugged into the circuit board. I don't think we have to remove them right now. And we have one of these odd sized batteries. If you want to fix this, you would need, it's a DenGaWa 9 amp hour. Well, that's a small battery. Typically these portable power packs will have 18 to 22 amp hour batteries. But let's look that up and see what that's going to cost, because this is dead. And we can confirm that by measuring it right here. I'll put this back on 60 volts. Touching the black probe to the black wire and the red probe to the red wire, and there's your 3 volts. So this battery is no good. And if you wanted to fix this power pack, you would need one of those. I don't have one at the moment, so at the moment we're stuck. So this is pretty well made though. Sometimes, before you unscrew the battery, oop, got a helper. Helper just came out. you might want to take a picture of this with your cell phone. But we got red to red, hard to make a mistake on that. And there's one black wire out over here, so black to black, red to red, no color confusion. So this would be very easy to put back together, even if some time passed between the time you took this apart and the time you put in the new battery. But if there's color confusion, make sure you mark this before you unscrew anything. Okay, this top screw is an 8mm. We're going to need two of them because we're spinning the bottom. Nope, it's not magnetic. Okay, this is going to be fun. Ow. Nope. Okay, we'll put the hardware back together so that we don't lose it. Another thing, much easier to use the screwdriver once you break it free. So when putting this back together, I'm thinking you want this side up, not the nut side on the top post. Now if you've got color confusion on these wires, good idea to put this back together. Who knows how much time is going to go by between now and getting the battery back, getting a new battery, then you forget where stuff goes. This way there's going to be no mistaking where those wires go. And on the bottom, well, you don't have to do it here because they're joined together. With this one. Okay, so in that way, no mistaking where stuff goes back together. We've got this out. Put our styrofoams back in. Just roughly put this back like that. Bag these screws till we can get back to it. Okay, all back together. It's not screwed down, just snapped together till we get a battery for it. Now, before we spend $30 for a new battery, we'll want to make sure that the rest of this unit is in good operating condition. So here's how you can do that. You can connect any good battery that you might have using the alligator clips to the unit. I want to make sure that that's a good battery, so we'll put our multimeter on the 60 volt scale. You can read anything up to 60 volts. So this 6,000 mil or 6 volt scale would not work because 12 volt would exceed that, would exceed 6 volts. So we have to have something higher than the voltage we want to read. That's why we put it on 60 on this meter. So put it here. Well, see what we got. And it's reading 13 volts, so we know we have a good battery. Should be more than enough. Perfect to run this power pack. Alright, so the first thing I'm going to do, I've got the switch turned on, the jump start switch, which then connects this battery to this unit. First thing I'm going to do is check the USB. I'm going to press the little button that turns on the USB. Not drawing any current at the moment. We have little over 5 volts. And this tiny meter that I have here is not drawing any juice, but we know the USB is working because when we turn it on, we can see 5 volts there. That's our charging voltage. So that part's working. Now it says here hold for light. And we can see our light came on. Turn it off now. Alright, next thing is compressor. Now, we don't want to just hear the compressor run, but we want to feel this to make sure that we've got some air actually coming out of the nozzle here. So, alright, let's try this. Oh, I can definitely feel air. Okay, so I definitely feel air coming out of here. Light worked, USB works. Looks like everything is in good working order on this device, so it's worth buying a battery for it because now we know that that's all that's wrong. Now, one little tip before you do this. I made sure that the screws, the nuts and bolts here were tight, and I bagged both the positive and negative battery wires with little plastic bags, and I held it here with elastic bands. And the reason you do that is you don't want these to touch inadvertently because that would short out this battery, and that would be very bad. So this prevents these two wires from touching each other and shorting out the new battery. So okay, easy way to test this to make sure that everything's in good working order. If we buy a new battery for this, this is going to work. Now, before we can order this battery, there are several things we need to note, and I've already made a list here. So the first thing, the make. Well, we noted that this is marked Leoch. So I'll leave you to pronounce that. And it's a DJW 12-9, meaning that it's a 12 volt 9 amp hour battery. So we write that down. Make, I'll say Leoch, model DJW 12-9. But that's not enough. We need to also measure the length, the width, and the height. Because there's no guarantee that the stuff you order today is going to come even close to what you're asking for. So I've got a little tape measure here. This is my wife's. It's actually better than anything I have, because we need to measure this both in imperial, in other words inches, and also metric or centimeters, because some manufacturers are going to give you the length, width, and height in inches, and others are going to give it to you in centimeters. So let's get both. Okay. Bring this across, and I'm getting roughly 5 7/8 inches, or maybe 4 3/4 centimeters. You don't have to be exact. If it's way off, obviously you're going to be able to tell. But this is a little over 5 3/4 inches, so I'll say 5 7/8 inches. I'll say 4 3/4 centimeters, and I'm going to write that down right now. Length, 5 3/4 inches. Is that what we said? Yep. So there's 2.54 centimeters to an inch. We had 5 3/4 inches, or roughly 14 3/4 centimeters in length. All right, let's measure the width. All right, I'm getting maybe 2 5/8 inches wide, or about 6 1/4 centimeters. Again, you don't have to get it exact. Double check that, make sure I wrote it down right. Yep. I'm actually getting more in like 2 3/8 inches wide, maybe 6 1/4 centimeters. All right, let me change this. 2 3/8. All right, now what about the height? And we're doing this because we want to make sure we order the right thing. I'm getting about 3 5/8 high, a little over 9 centimeters high. Let's double check that. Yep, 3 5/8 high, a little over 9 centimeters. Okay, so we've got our dimensions. Now the next thing, we want to pay attention to the connections. These are called nut and bolt connections. On this larger battery, that's also a larger nut and bolt connection. So we want to make sure that we're going to get a battery with the right connections, because very often these will come with push-on type connectors. They're made for plugs, spade type connectors that push on. These are going to connect with nuts and bolts, so we want to make sure that whatever battery we're ordering is pictured with nut and bolt connections, not with some other kind of terminal connections. So nut and bolt, we want to write that down. What type of terminals do we have? Right here, terminal type. nut and bolt. We'll abbreviate that, NB. Nut and bolt. Now, something that people don't quite understand. There are left-hand batteries and right-hand batteries. What you do, you stand with the terminals to your stomach. And now you got a left hand and a right hand. We're looking for the positive terminal. And if I put this battery to my stomach, just like this, the positive terminal is near my left hand. So this is a left-hand battery. Because you could get one of these where these terminals polarity would be reversed. Positive would be on this side, negative would be on that side. What difference does that make? Well, the way these things are made today, let's say that this is laying in the jump starter like this. This cable, the cable that connects to the backside, the negative, it's going to be so short, it's barely going to make contact here. And this one that's connected to the top will be a little bit longer to make it to the top, because you know the shortest distance between 2 points is a straight line. This has to be the diagonal coming across like that, so this is going to be a little bit longer. Now if you reverse these, the longer cable will easily make it to the bottom, but the short cable is going to come up short. It's only going to make it to, say, here. There won't be enough length to connect it to the top. So it creates a big problem. You have to be absolutely sure that you're ordering the left hand or right hand. And again, because pointing this towards my stomach, this is on my left side, this is a left-hand battery. And likewise, this larger battery, this is also a left-hand battery. Now sometimes on a larger battery, the connections are in the middle. If they're exactly in the middle of the battery, it doesn't make any difference because you can just flip it. But most of the time, they're on one side or the other. So you put the terminal side up against your stomach. If positive is on the left, it's a left-hand battery. If positive is on the right, it's a right-hand battery. So we're going to write that down. Is it a left hand or a right hand? We want a left hand. Nut and bolt terminal, left hand. Put an L there. And then something that people aren't aware of, the weight of the battery. Why do we want to measure the weight of the battery? Because this is going to tell you a rough idea of how much lead is in this. This is a lead acid battery. Let's get the weight, both in kilograms and grams here. So this is 2.738 kilograms. I'm writing that down. Let's change it to pounds. Or a little over 6 pounds. 6.035 pounds. Write that down. Okay, we've written it. Now if somebody is trying to sell you a battery and it's significantly lighter than that, let's say it's only 5 pounds, then that would mean that this battery they're trying to sell you has a lot less lead in it, and presumably then it won't last as long, it won't hold a charge as long in service. So this is the OEM style. If they're trying to sell you something that weighs a little bit more but it's the same physical size, then presumably it's going to last longer than this OEM battery. So these are all the factors. Now we can go back online and, armed with all this, order exactly the right thing. And if what we receive is not the right thing, then it's not going to be our fault, because we have all the parameters right here. If they send us the wrong thing, it's going to be because it's their fault. And very often on Amazon, that's exactly what happens. But let's go look, see how we make out. Okay, we're here at the Jungle website. Our search criteria, we've typed in LEOC DJW 12-9.0 12 volt 9 amp hour battery, right up here, left corner. And note Amazon's overall pick. $24.99, price is right. I wonder how many people will just take that recommendation, order this battery, receive it, only to find out it's not the right thing. Now, do you see what's wrong with it? Look at those terminals. Those are F2 terminals. They're made for push-on connectors. They're not made for nut and bolt connections. So overall pick or not, this is not the right battery. Okay, what about this one? Same price, correct terminals. These are nut and bolt terminals. Positives on the left-hand side. That's what we want. Now we scroll down and look at the size. I'm seeing that this size is a little larger than we measured. And note also that the size and the product dimensions are exactly the same. Generally, one of those is the package size, and one of those is the actual item size. So something's not right there. So either there's a mistake in the listing, or this battery is actually larger than the battery that we need. Okay, what about this one? This one is from a Schumacher Jump Starter. The model of that Schumacher is BE, either an O or a 0, don't know which it is, 1254. So it's BEO 1254. It's a similar size jump starter. And the battery, the OEM battery, is a WP7-12. It's exactly the same size as the battery from our Duracell Jump Starter, the OEM battery anyways. So if this one fits the Schumacher, it ought to fit our Duracell. So if I were ordering a battery today, this would be the one I would probably order. Well, I didn't do that because on a subsequent trip to the store, I picked up this Schumacher. It has a good battery, takes a charge, holds a charge, has good alligator clips. They're in very good condition. Light works. But whoever owned this cut the air hose off of it. Now the pump does work. And air definitely comes out of this hose. So at first I'm thinking, well, all I have to do is replace the hose. But the previous owner also cut off whatever was here that you wrap the hose around. So I'm thinking, take this apart, take this battery, which is the same size as the battery we removed from the Duracell, transfer it into the Duracell, and we'll have one perfect unit. Additionally, we can take that air pump, put it in the Stanley. We can take these alligator clips, which are in excellent condition, transfer these to the Stanley as well, and then the Stanley will just need a battery. So it looks like we're going to be able to make 2 good ones from 3 bad ones. Now it would be very easy to replace that air hose. I've got air hose, but I'd have to come up with some sort of wrapper. So I think it's just easier to transfer this battery to that. So that's what we're going to do today. Pretty tight quarters here. Let's see what we can do. Oh, gonna need 2 for sure. Now here's the color confusion that we were talking about earlier. We have a black wire here going to red wires. That makes sense. So we're going to put this nut back on right away so that we don't get confused about that. Now here we've got another black wire going to black wires. So if we don't do this right away, then if we decide to fix this at some later time, it'd be very easy to get that confused. Okay, now here's our battery. Well, there is not a tenth of an inch to spare here. Well, let's see how we make out. And we have another styrofoam to put here. Okay, looks like we've got it together. Okay, we've got it all back together. Looks good. Let's see how it works. We'll test out the USB first. So push this button. No amps. We have a little over 5 volts, so USB charge is working. All right, what about the light? It says that we should, light is off right now. It says to hold this button for the light. Light works. Light goes off. How's our battery indicator? Be this one. Nope, that's the air compressor. Air does come out of the hose. This must be just batteries showing right now. All the lights are lit. Now, this is a small power pack. It's not going to jump start an 8-cylinder engine. I wouldn't even expect this to jump start a 6-cylinder. This is probably, I mean, no question this would jump start a lawnmower, a snowblower, a little 4-cylinder. Still neat unit, quite useful. We fixed it without spending any money. And we also know that that other WP7 battery works in it. So I hope this helps someone. I hope you are encouraged to fix your jump starter by changing the dead battery. I think anytime you can fix a $100 appliance for $25, $30, it sure makes sense to me. Even if that took you 1 hour, you would be compensated to the tune of $70 to $75 for what's really a very, very simple, easy job. So I hope this helps someone. Thanks for watching.